in both of these last examples, there are some kind of specific things we need to watch out for. So you can try them on your own, or if you want to get them set up with me first and then try them, either way. All right, so for this first one, again, just like usual, we are going to start by factoring our denominator. So let's see, this is going to factor to x minus 1 times x minus 1. And I could rewrite that. I could really think of that as x minus 1 squared. All right, so I'm actually going to rewrite this as x minus 1 squared. I was going to write it out twice, but I'm just going to, oops. All right, maybe. I don't know why my eraser is not erasing. All right, x minus 1 squared. And so here's the thing that's going to be a little tricky for us. When we have x minus 1 squared, we're going to think of this as a repeated linear factor. And the thing that I think can be hard to understand is instead of having just an x minus 1 squared here, or an x minus 1 and an x minus 1, we're actually going to write the first power of x minus 1. And then over here, we're going to have a second power of x minus 1. And so if you want to talk through this about like why we have to do it this way, that's something I'd be happy to talk to you about like outside of class if you want to come by office hours. But we're going to treat this like we have our linear factor of x minus 1 here. And this x minus 1 squared, we're treating this like a repeated linear factor. It's not a quadratic, so it still just gets a b on top. So that's, I think, the setup that's going to make this one kind of tricky. From here, though, if you feel good about it, we can solve this like we normally would. If you want to pause the video and try it on your own, I'm going to keep rolling. So again, I'm going to multiply it by our least common denominator, which is 2 factors of x minus 1. When we distribute that, we're going to get a 3x equals, when I get to my first term, 1 factor of x minus 1 will cancel from the top and bottom. So I'm left with 1 factor on top. And then both factors will cancel with my b. All right, so this looks relatively simple. Again, since I have linear factors, I think the easiest strategy is to just pick what we want to use for x. I've got to find an a and a b, so I need 2 different x values to solve for 2 variables. I know that using x equals 1 will be an easy choice because that will make x minus 1 become 0. And since I don't have like b times an expression of x, you could use literally any other number you want. I'm just going to use 2 because then that will make that a 1a, and that also seems kind of easy. All right, so if x equals 1, 3 times 1 is 3. A times 1 minus 1 is a times 0. So I just get 3 equals b. If x is equal to 2, my left-hand side is a 6. I get a times 2 minus 1, so I get a plus b. But remember, we already know that b is 3, so 6 equals a plus 3. So a is equal to 3. All right, so when we do our rewrite, we have that we are integrating, I'm just going to come over here, we're going to integrate 3 over x minus 1 plus 3 over x minus 1 squared. Now we have to be careful here because that second expression there, that is not natural log. I'll rewrite it like this. So I would think about doing a u sub for the second part. So like if u is x minus 1, well, my du is just dx. So really this piece is going to be 1 over u squared. And remember, I've got to treat that with the power rule. That is not natural log. So I just have to be careful because some of our fractions are going to look so similar. All right, so I'm going to get 3 times the natural log of the absolute value of x minus 1 plus 3 times, I'm using the power rule, so I'm going to add 1 to my exponent, and divide by my new exponent. So that's going to be 3 divided by a -1. That's just going to change the sign. So I'm just going to erase that and write minus 3. And I'm going to get 1 over u du. So that would be times like 1 over u was x minus 1 plus c. So sorry, 1 over u plus c. All right, so again, my final answer could look like that. Or I could rewrite this as 3 natural log absolute value of x minus 1 minus 3 over x minus 1 plus c. All right, this very last example, again, there's something kind of specific that we need to watch out for here that's going to happen. So out to the side, I'm going to factor my denominator, and I could pull out a GCF of x squared, and then I'm left with x minus 1. And so here's the thing that I think is tricky, is that I'm not going to treat x squared like a quadratic. We could probably work it out that way, but what would make this a lot easier is to treat it like a repeated linear factor. Like x is linear, and we have 2 factors of x. So just like we did above, when I have a repeated linear, I'm going to first write my linear factor. Then I'm going to have my linear factor now to the second power. And then I've got my c over x minus 1. All right, so again, when we go to multiply by our lowest common denominator, everything gets multiplied by that. So I'm going to get 1 equals, when I multiply this with a, only one single factor of x is going to cancel with my denominator. So I'm going to be left with a times x minus 1. When I get to my b term, my term with the b on top, my x squareds will cancel out. So I'm going to have b times x minus 1. And when I get to c, my x minus 1s will cancel out, so I have c times x squared. Okay, so again, I think what would be easier here is to pick 3 values of x to use those to solve. So let's see, I can see x equals 0 will be helpful. I can see that x equals 1 will be helpful. And again, for my third value, I could pick anything I want. There's nothing else jumping out at me. So I'm just going to pick like x equals 2, keep it simple. All right, so when x is 0, I get 1 equals, all of my junk for a cancels out, plus b times 0 minus 1. So that's a -1b. And then c times 0 squared. So I get 1 equals -b, so b equals -1. All right, when I plug in a 1 for x, I still have a 1 on the left. This becomes a times 1 minus 1, so a times 0, that cancels out. I have a b times 1 minus 1, so a b times 0, and then a c times 1 squared. So I get c equals 1. And then finally, when I plug in x equals 2, or whatever other number we want, I'm going to get a, let's see, 2a times 1 plus, let's see, 2 minus 1 is 1, so plus b, plus 2 squared times c, so plus 4c. All right, so when I go to clean that up, remember, I already know that b equals -1 and c equals 1. So I get 2a minus 1 plus 4 so a is also -1. All right, so now when we go to do our rewrite, I'm really integrating a over x, so -1 over x plus b over x squared. I'm going to do -1 over x squared plus c over x minus 1, so plus 1 over x minus 1. So I have to be real careful. That one in the middle is not like the one on the left and the right. I'm going to get on the left negative ln absolute value of x. But in the middle here, I need to remember to treat this like x to the negative 2 power. So using that power rule, or if you ever just want to do this workout to the side, when I integrate this, I'm going to add 1 to my exponent, divide by my new exponent, so that negative 1 becomes a positive 1. So I get 1 over x. And then I've got another natural log absolute value of x minus 1. All right, so again, the calculus here isn't so bad. It's all the algebra that we've got to work through. All right, after this, we have 2 more advanced techniques to go.